Meet Steven, an average 16-year-old boy living in a polluted world. Steven is unaware of the very impact his daily routine has on our society. He starts each morning by getting out of bed just like the rest of us. He brushes his teeth just like the rest of us. And whoa Steven, he left the faucet leaking again. Steven leaving the faucet running contributes to global warming. Water takes energy to move, which causes unnecessary greenhouse emissions. Now, Steven's going to get dressed, just like the rest of us. And now he is, whoa Steven, he left the lights on again, just as he does every morning before he leaves the school, contributing to the CO2 in the atmosphere by wasting valuable electricity. The EPA estimates that each year, Americans waste over 1 trillion gallons of water on leaky faucets, malfunctioning toilets, and errant sprinkler systems. That's 40 million swimming pools, which leads to an extra 4 million metric tons of CO2 in our atmosphere. Leaving the light on has a huge impact on our environment. If Steven turns off unneeded lights, like he did today, for 2 hours every day for a week, he can save 8 pounds of CO2 from being emitted. On average, a car in the United States releases 4.7 metric tons of CO2 a year. There are 258.8 million cars in the US. That's 1.2 trillion metric tons of CO2 coming from our cars every single year. From this data, it is clear we're emitting a ton of carbon. What if CO2 could help us generate more electricity and shift our world to a more sustainable future? Our solution for better long-term management of CO2 in the atmosphere is the CO2 Sun Cell. It uses captured CO2 to store solar energy both efficiently and economically. We start by capturing energy from the sun, which is then used to heat a molten salt component and cool CO2 to dry ice. By heating the dry ice with molten salts, CO2 turns into a supercritical fluid, a state of matter that is neither liquid nor gas. Supercritical CO2 is much more efficient than steam. This fluid would be processed in a turbine known as a CO2 sun cell, which would harness the CO2's energy at a high efficiency of 68% return as opposed to 61% turn that gas power plants have, therefore making the supercritical fluid a super efficient solution. Because the battery can be charged during the day and expended during the night, this fixes the problem of intermittency, using an